Before we get started on today's lesson, are there any questions over the homework or any problems you want to look at? Which one? Okay, can I borrow for a second? So Jalen, it is the same note sheets as yesterday.
All right.
Yes. You're welcome. All right, guys, so we're looking at a problem from the homework that we're going to look at before we get started. So this one here, we want to factor the following polynomial. So the first thing we look for is a greatest common factor, and 2 is a greatest common factor, which we will factor out. When we factor 2 out, we get 4g squared minus 5g minus 6. Then we would have 2 sets of parentheses with 3 spaces. Since the third term is negative, our signs would be opposite. And we would look at the factors of 4g and 6. Well, the factors of g squared would be g and g. Now the factors of 4 would be 1 and 4 or 2 and 2. The factors of 6 are 1 and 6 or 2 and 3. Now since we've removed all the greatest common factors already, that means inside these 2 parentheses there cannot be any common factors. So if we look at 2 and 2, well, with 2 and 2, 1 and 6 or 2 and 3, in either way we set it up, there will be a common factor of 2. As if I put 2g and 2g, I'll write it below. Well, if I put 1 and 6, we'd have a common factor of 2. So that doesn't work. And even if I switch it, we'd still have a common factor of 2. 2 and 3 or 3 and 2, we would still have a common factor of 2. So that means 2 and 2 cannot be a possible setup if this is going to factor. So that means we're looking at 1 and 4. So I can say 1, 4 and 1. And we can try 3 and 2. So I just plug them in to see where we're going. And last but not least, we can check. So 4 times negative 2 would be negative 8g. 3 times g would be plus 3g. And negative 8 plus 3 would be negative 5g, which is what we wanted. So that right there would be the solution. That's it. Any other questions on these here? Any other questions on any of the assignments? It will probably be next week, because we have, today we'll finish 3-3. Tomorrow will be 3-4-1 and 3-4-2. There will be an assignment for both. Next week we have 3-5-1 and 3-5-2. So that'll be Monday, Tuesday. Wednesday will be 3-6. I think it'll just take a day. It might take 2. We'll see. And then we'll officially finish either Wednesday or Thursday. If we finish Wednesday, makeup day would be Thursday. If we finish Thursday, the makeup day would be Friday, depending on how 3-6 goes. Yes? There weren't any from yesterday because we didn't quite finish it, and I planned it that way. Because the first part that we covered was solving the quadratic equations by graphing. And for the assignment, there are some that you're going to solve it by graphing. You'll need a graphing calculator or a tool to graph, because I'm not going to make you graph these by hand. So most likely this here, it's definitely not going to take us all hour. I think the longest it's taken out of the other 2 is like 16 minutes. So I'm giving you the rest of the time to work on that assignment. Okay? So tomorrow it will be a full piece. It may or may not take the whole time. We'll see. Because it is broken up into 2 parts. We did this one yesterday, yes? Or did we stop here? Okay, so this one here was the other type of problem that we could use the square root method by. Now, when we use the square root method, the way that it works is either we have the variable squared is the only one we have. It's only going to be x squared or y squared is the only thing that shows up. We don't have anything to the first power. We don't have x to the first or y to the first, any variable to the first power. Here, it also works because our variable is to the first power, but it's inside parentheses that are being squared. And there's no other variable anywhere else. Now, if this had been equal to 5x, we wouldn't be able to do it because we have a variable inside and outside, one that's squared and one that's not. But here, because all the variables are contained inside the parentheses and are being squared, we can use the square root method, because we're going to get it by itself first. Now, whenever we have it set up in this way, we want to get the set of parentheses that are being squared by themselves. Well, the only thing that's interacting with this set of parentheses that's being squared is the 2/5 because it's being multiplied. So to undo this, well, we could divide both sides by 2/5, or we can multiply both sides by what? Over 2. If we were just plugging it straight into the calculator, dividing both sides by 2/5 works just fine. 5 divided by 2/5, the calculator will tell us. If we're having to do this by hand or we don't have a calculator available, doing this multiplication is a little bit easier. Because when I come over here, 5 times 5/2, we multiply by the numerator, the top of the fraction. 5 times 5 is over 2. And it'd be the same thing if we had done 5 divided by 2/5, we would get to the same answer. Now on the other side, we still have x plus 3 squared. Have we gotten the thing that's being squared by itself? As if we look at the set of parentheses, is there anything else being multiplied by it? Anything being added or subtracted from it? No, because we just have this set of parentheses squared by itself. So we can use the square root method, take the square root of both sides, because the square root and a square will cancel, leaving us with x plus 3 is equal to plus or minus. Because whenever we take the square root of both sides, we have to include the plus or minus. Now we're going to want to reduce the 25, square root of 25/2. Now the graphing calculator is going to give you a decimal answer, because we can take the square root of 25. What is the square root of 25? 5. What's the square root of 2? Well, there's not a whole number, because there's not a number multiplied by itself that gives us 2. There is, but it is like 1 point something going on. It is an irrational solution. It's a non-repeating, non-terminating decimal. So if we plug that into the calculator, it would give us the decimal form. It'll give us the approximation of it. But what we can do also is I can break it up like this here. Square root of 25 over the square root of 2. And the yellow calculators, the TI-30XS, if it's written in this form or typed in this form and you hit enter, it will actually leave it in radical form. It'll simplify it down for us, where we don't have a decimal. And really what it's doing is, well, exactly as we said, the square root of 25 is 5, but we can't take the square root of 2. Now, we can't leave a square root in the denominator, because really what this is saying is that we're dividing by a non-repeating, non-terminating decimal. We don't like that. In mathematics, it's just not proper to leave it like that. So we want to keep it so that the denominator is a whole number. So to do this, to simplify it, we're going to multiply the fraction by 1. Well, not actually a 1, but another representation of 1 in the form of square root of 2 over the square root of 2. As well, anything divided by itself is 1. So multiplying the top and bottom by the square root of 2, essentially we're just multiplying the thing by 1. Multiplying something by 1 does not actually change the number. It just changes how it looks in this way. So the numerator, well, it's just going to be 5 square root of 2. 5 times the square root of 2 is 5 square root of 2. They just multiply together. Now the denominator, we'll have the square root of 2 times itself. Isn't that this the same as saying the square root of 2 squared? Well, the square root and square would cancel, leaving us with what? 2. So if we'd have typed 5, or the square root of 25, divided by the square root of 2 into the yellow calculators, the TI-30XS, and hit enter, it actually would have told us 5 square root of 2 over 2. Now, if we'd have typed the square root of 25 halves in, it would have given us the decimal. It needs it broken up. But it would have given us this here. Any questions on this here so far? Now on the test or on the assignments, I will take it in this form. If you get an answer that is an irrational number, because of the square root of 2 is irrational, I will take it in this radical form. Even if the back of the book doesn't give it in that form, I will still take it with the radical. Well, we're almost done. It might give you the decimal approximation. And you can still check it, and I'll show you how we'll check it to make sure we got the same thing. Now, is x by itself? Well, now we have the plus 3, so we need to do one last step to get x by itself. And that would be to subtract 3 from both sides, because those would become 0, leaving x by itself is equal to negative 3 plus or minus 5 square root of 2 over 2. And that there would be the answer. Because as we already said, or I've said multiple times now, 5 square root of 2 over 2 is irrational. Yes, it contains a decimal number that is non-repeating, non-terminating. Which means I can't just add 3 to it or subtract 3 from it. Because those are two different numbers, because it's not actually just 5 square root of 2 over 2 to something that I can add to it. I need the decimal to be able to actually add or subtract. They're not like terms. So really, this is as far as we can take it without turning that 5 square root of 2 over 2 into a decimal. And I will take that. Now, if it had been 4, can I take negative 3 plus 4? Oh yeah, negative 3 plus 4, we can add those. If it's negative 3 minus 4, we can subtract those. If it's two numbers that we can add and subtract, you're going to need to add and subtract them. Does that make sense? Because here, I can't just add negative 3 and 5. They're not like terms because of that radical. But if we had, say, negative 3 plus or minus 4, well, I can take negative 3 plus 4 is 1. Negative 3 minus 4 is negative 7. If I can add and subtract them, we're going to add and subtract them. Okay. Now, as Caleb was asking, how can we see it and kind of match it up with the back if it doesn't give us it in this form? Is that I can just take the calculator and say, as it is coming in two forms, negative 3 plus 5 square root of 2 over 2. And we can add them together. Negative 3 plus 5 square root of 2 over 2. Now the graphing calculator, if you type this in, it's just going to give you the decimal approximation. The TI30XS, as long as the number is not too big, it will give you the radical form as one whole. But all I need to do is convert it over to a decimal, 0.535533906 is the decimal approximation of this answer here. And then we can do the same thing, but this time the other form of it is that we're taking -3 minus 5 squared of 2 over 2. And really it's approximate, not equals, but that's fine. -6.535533906 would be the other one. So if the textbook, especially if you're checking to make sure you got the right answer in the back, gives you a decimal, all I've got to do is convert this over to decimal form and see do they match up. Does they match up? Yes. But that's it. Now, with this solution, would this be, could we have found this answer by graphing? Is this really, this decimal, a nice number? No. I mean, 0.5, we would have to do a little bit of work, as we saw yesterday with 4.5, I believe, or 1.5 as the solution. We had to manipulate the graph a little bit to find it. Here, it's going to be even more difficult to find this, because it might give us 0.5355, but depending on the pixel approximation that the calculator is using to get the numbers, it might be off. As we've seen, I think we did it in here where we found some of the values, and the answer was 1.5, but it gave it to us as 1.49 repeated. It was a little off, so this here might be a little off also. So with these irrational numbers, these irrational answers, it's sometimes better to actually work it out by hand or we have ways to calculate it that will work a little bit better. Graphing works well if the answers are whole numbers, because if they're not whole numbers, we'll have to use a little bit different method to find it. Any questions on this here? Let's look at one more like this here, then one more with the parentheses, and then we have one more and we're done. So we have a grand total of 3 left. Now this problem here, the only variable we have is x squared, and we only have it once. Now it could work out that we have x squared in more than one place, but as long as we don't have x to the first power, we can still use the square root method. So here, we can use the square root method because we only have x squared. But what would be the first thing we need to do to solve for x using the square root method? Well, we need to get it by itself, yes? So to get it by itself, we would do what first? We'd subtract 14. Because the square root method is a little different than most of the other methods that we're going to use, in that we don't get everything on the same side. For the square root method, we're trying to get the variable that is squared, or the set of parentheses that's being squared, by itself. So these would cancel, leaving us with 2/3. X squared is equal to 6. Now what can we do next? We can divide by 2/3, and that would work just fine. Or we can multiply by 3/2. Either works, because dividing by 2/3 works just fine, especially if we have a calculator that'll do it for us. Because these will cancel out, because 3 times 2 is 6, 2 times 3 is 6, so 6 divided by 6 is 1. Because if we do the multiplication with it flipped, on top we have 2 times 3, which is 6. The bottom is 2 times 3, which is, so it gives us 1. It's a nice little trick to do it to get those to cancel, leaving us with x squared. Because over here, 6 times 3, we always multiply whole numbers by the numerator. 6 times 3 is
18.
Divided by 2 is?
Is 18 divided by 2 is 9.
Mm-hmm. But that would be about the same thing with what we would do, bless you, if we would have divided. Because whenever we divide a fraction, we don't actually divide. We change it from division to multiplication and flip the fraction, the second one. Well, if I flip 2/3, it becomes 3/2, and we're multiplying. So we get to the same place. It does the same thing. The 6 divided by 2/3 would be 6 times 3/2, which gets us to 9. Now, what do we do lastly? Square root both sides. Now the square root of x squared is? X is equal to the square root of 9 would be almost plus or minus 3. Because since we square rooted both sides, we have to add the plus or minus. Now, if we'd just taken the square root of 9, it would be 3. But because we're taking the square root of both sides, we have to add the plus or minus. Now, in geometry, or when we talked about just simplifying radicals, it would have been just 3. Because in geometry, when we took the square root, we were talking about distances or lengths. Can we ever have a negative length? Well, no. So we don't really talk about it in geometry or anything before this too much because we don't consider the positive or negative case. We only consider the positive. But here, because again, we're talking more in an abstract sense, that the solution could be positive or negative, we don't have restrictions on it being real lengths or measures to it. So it'd be positive or negative 3. Could we have solved this by graphing?
Yes.
Because we got what? Whole number answers. Now, thinking forward about the test, there will be certain questions on there that are restricted on how you solve them. Because there could be parts of the test that ask you to solve the following quadratics by graphing. So we would graph them to find the solution. There's going to be some that ask you to solve it by factoring. But for factoring any of the other methods, if we get whole number answers, could I graph it to check to make sure I got the right answer? Well, yeah, we can use graphing or we can use the other methods to find the solutions. Also, I will say this now and I will say it again later, just because you don't remember how to solve it by the method that is asked, don't just skip it. Because if you do remember how to solve it by, we'll eventually learn the quadratic formula, or completing the square, or factoring, or graphing, or one of the other methods you do remember, go on and solve it and get the answer. Because you will get the points for getting the correct answer, and working it, you may just lose the 1 or 2 points for not doing it by the suggested method, or the required method. But that's still 1 or 2 points out of the whole, which could be 5 or 6. It's better to get the majority of the points than to lose all of them just because you don't remember that one method or don't feel comfortable with it, okay? Any other questions on this here? We're going to look at this one here and one else, so we have this one and one more left to do. So this here, we do have a set of parentheses squared, and there are no other variables anywhere else besides inside the parentheses, yes?
Yes.
So we can use the square root method. Well, what can we do first? Since we do have the set of parentheses squared and no other variable, then we can get it by itself and use the square root method. Now, as you're saying, yes, I would factor it out if I had like 5x over here or had another x outside those parentheses, then I would need to factor it out. and condense. But here, because the square, or the x minus 4, there's only one and it's being squared. Well, if I take the square root of it, it'll simplify that out. Now, when we divide by 2, I'm left with x minus 4 squared equals negative 5/2. Now, what do we do next? We would square root it. Because we could, exactly, you're wanting to do the x minus 4 times x minus 4, multiply it by itself. And that would get us to the same spot. But since it is being multiplied by itself, we can take that square root. These would cancel, leaving us with x minus 4 is equal to plus or minus. Let's go on and just get the decimal version for this here. If you have a calculator, go on and type that in, see what you get. Is that what you got? And it's going to give you an error. The graphing calculator, we will eventually be able to utilize it to find this. Huh? Did it give you a number?
No, I did. I got error.
Yeah, and that's fine. No, because when we're finding a square root, we're trying to find what number times itself gives us the number inside the radical. Yes? So if the number, so like the square root of 4 would be 2, because 2 times 2 gives us 4, yes? Well, here we're looking for a number that times itself and is negative, yes? Well, positive times a positive is a positive, yes? A negative times a negative is a positive also. So is it possible to multiply a number by itself and it be negative? No. So that's why we get an error. So at this point here, this here is no. But after tomorrow and Friday, we will actually be able to find the solutions. There is a way to find the solutions for this here. It's just dealing with this tricky square root, or the square root of a negative. All right, guys, so we're almost done. Now, solving by factoring.
Now we got 2 x's.
Now, we've done this already. We did this in 3.13, where we actually solved by factoring. We factored to 2 sets of parentheses, had it equal 0, set those equal to 0, and solved. It is by our zero product property. Any 2 or more things multiply together to equal 0. One of them has to be 0. And we did that. So I feel at this point, you all feel comfortable with this here? Okay. Because these are the same thing. Now, finding the zeros is actually doing the exact same thing we've been doing. Because what we did today and what we did yesterday, especially with graphing, is we're trying to find the value of x that makes the function equal what? 0. So we're finding the what? The zeros of the function, because those values of x make the function equal 0. That's all it's saying. Because when we found it or solved it by graphing, we were finding the x-intercepts because the value of y was 0. When we solve it by factoring, we're finding the zeros of the function. Yeah. They will also call it roots, because if we find the roots, it's just factoring it down and seeing what values of x would make the function equal 0. They're just different names for the same thing. The one that I want to look at, and the last one we're going to do today, is number 9, x squared minus 8x. This one here isn't any more difficult or any more challenging than what we did. It's just one little step to it. Now, again, we're trying to see what value of x will make this function equal Is there a greatest common factor between x squared and 8x? X. There's x in common. So we can factor it out. So if I factor an x out of x squared, I'm left with x minus 8. So I can factor that x out. Because all the ones we've done up to so far, this point so far, has had a squared term, may or may not have a term with x, but then we had a constant term, a number without x. Here's the first one we've really dealt with that did not have a constant term, a number by itself, added or subtracted to it. And since we don't have it, well, between these two here, there is a greatest common factor of x that we can factor out. Now, we can't divide it out like we did with a number. We had a greatest common factor of 2, because if we divided this by x, we would have removed this one solution from the entire equation. We need both. Well, now we do have two things multiplied together to equal 0, yes? So one of them has to be 0. So we were saying that x is equal to 0, or x minus 8 is equal to the one, x equals 0, is x already by itself? So x is 0. Now we just need to find the other one. And that's it. Questions on this here? Questions on this here? This is the assignment here, and we are done for today, and we are finished with 3.3. So we'll start 3.4 tomorrow.